Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on analytical dynamics or classical mechanics, chapter Lagrangian dynamics, in which I will solve a problem. Problem is discuss the motion of a uniform heavy rod turning about one end which is fixed. Let OA be the rod with mass M and length 2A, OA equal to 2A, whose one end point O is fixed at O, then it is turned. Let at any time t, the inclination of the rod to the vertical, this is the vertical, is theta. Vertical means z axis is assumed as vertical. This rod makes angle theta with the vertical, and phi be the angle which the vertical plane A prime through the rod makes with x-axis. Let at time t, the coordinates of a point P on the rod be x, y, z. Let PQ be an small element. This PQ be an small element on the rod such that PQ equal to dr. Now we compare the spherical polar coordinates with Cartesian coordinate. Then we will get x equal to r sin theta cos phi, y equal to r sin theta sin phi, z equal to r cos theta. This is number 1 equation. Differentiating both sides with respect to t. Differentiation of x with respect to t is x dot. Here r, we differentiate sin theta, we will get cos theta, then theta dot, and cos phi remains same, plus r sin theta remains same. Differentiation of cos phi is minus sin phi, phi dot. Similarly, y dot equal to r, differentiation of sin theta is cos theta, theta dot, sin phi remains same, plus r sin theta, differentiation of sin phi is cos phi, phi dot. Here z dot equal to r, differentiation of cos theta is minus sin theta, theta dot. Now velocity square of the point P will be x dot square plus y dot square plus z dot square. X dot means velocity component along x-axis, y dot means velocity component along y-axis, and z dot means velocity component along z-axis. Therefore, velocity square of P will be x dot square plus y dot square plus z dot square. Squaring this, we will get up to this y dot square equal to r square cos square theta, theta dot square sin square phi, plus this r square sin square theta cos square phi, phi dot square, plus 2 into this and this. This is 2r square theta dot phi dot cos theta sin theta cos phi sin phi, plus z dot square equal to r square sin square theta, theta dot square. Here this term and this term cancel, plus minus. Let us take common r square cos square theta, theta dot square. Here remains cos square phi and here sin square phi. Here we take common r square sin square theta phi dot square. Here remains sin square phi and here remains cos square phi. Cos square phi plus sin square phi equal to 1. Here sin square phi plus cos square phi equal to 1. So remains here r square cos square theta theta dot square. Here r square sin square theta phi dot square. Here r square sin square theta theta dot square. Now take common r square theta dot square. Here remains cos square theta. Here sin square theta. And remaining term this. Here cos square theta plus sin square theta equal to 1. So this remains r square theta dot square plus r square sin square theta phi dot square. Here take common r square remains theta dot square plus sin square theta phi dot square. Since given that mass of the rod is m and length is 2a, therefore mass of unit length of the rod will be m by 2a, implies that mass of dr length of the rod equal to m by 2a multiplied dr. This dr be the pq portion, length of the pq portion is dr. Therefore mass of pq equal to m by 2a multiplied dr. Therefore kinetic energy of the small element dr equal to half mass into velocity square. Half mass of the small element be m by 2a into dr. Velocity square equal to, this is r square under bracket theta square plus sin square theta phi dot square, and by rearranging we get equation 3. This is the kinetic energy of the small element dr. Now kinetic energy of entire rod OA will be integration of this part taking limit 0 to 2a, 2a be the length. Here we see that this integration is with respect to r. So these terms will be treated as constant. So we take these outside and only remains integration limit 0 to 2a r square dr. Integration of r square equal to r cube by 3, and putting the value of the limit, here we get 2a to the power 3 by 3. Here 2a and here 2a cube. So 1 2a will be cancelled, remains only 2a square by 3. Here 2a will be cancelled. So remains only half into m. This term theta dot square plus sin square theta multiply phi dot square multiply 2a square by 3. This equal to half 4 by 3, 2 square equal to 4, 4 by 3 ma square under bracket theta dot square plus phi dot square sin square theta. This is T, kinetic energy. Potential energy V. Now we find the potential energy of the rod. Since the center of gravity of the rod is at the middle point of the rod, and the distance from O to the middle point of the rod will be A, because length of the rod is 2a. So O to G means center of gravity equal to A, and its projection along Z axis will be A cos theta, means vertically downward. OZ be vertically downward, and loss in potential energy will be mg A cos theta, and so we write minus V. This is V be the potential energy, minus V equal to mg A cos theta plus constant. This is phi. Now differentiating T with respect to theta dot, we will get 4 by 3 ama square theta dot. Differentiating this. Partial derivative of t with respect to theta equal to 4 by 3 ma square. Here theta dot square is treated as constant, so 0. So remains 4 by 3 ma square. Here phi dot square. Here 2 sin theta cos theta and 2 cancel. So here 4 by 3. Here cos theta. This is 7. Partial derivative of v with respect to theta. Here this is mga sin theta. Partial derivative of t with respect to phi dot here. So this will be 4 by 3 ma square phi dot sin square theta. Partial derivative of t with respect to phi. Here this t does not contain phi, so this will be 0. Similarly, v does not contain phi explicitly, so this derivative will also be 0. These are equations 6, 7, 8, 9, 10, 11. Now Lagrange's equation of motion will be d by dt partial derivative of t with respect to theta dot minus partial derivative of t with respect to theta equal to minus partial derivative of v with respect to theta. And we have another variable phi, d by dt partial derivative of t with respect to phi dot minus partial derivative of t with respect to phi equal to minus partial derivative of v with respect to phi. Using 6, 7, 8, 9, 10, 11 in 12, this is 12, we get d by dt. Here value of this is 4 by 3 ma square theta dot. Value of this is 4 by 3 ma square phi dot square sin theta cos theta, and value of this is minus mga sin theta. And we take this a cancel from each term, so remains 4 by 3 ma square. Derivative of theta dot is theta double dot, and this remains same, only we have only one single power of a. Here we do not write a right side, and also we replace m from each term. We take common 4 by 3a. Here theta double dot minus phi dot square sin theta cos theta, right side minus g sin theta. This is number 13. From second equation of 12 we get d by dt. Here partial derivative of t with respect to phi dot, this value 9, and we put this. Here we take 4 by 3 ma square outside, so remains d by dt phi dot sin square theta equal to 0. Integrating both sides, we get phi dot sin square theta equal to constant h. Implies that phi dot equal to h by sin square theta. This is 14. Using this value in 13, here phi dot square, we put value of phi dot here, and we get 4 by 3 a theta double dot. In place of phi dot we put this, and we get h square cos theta by sin cube theta equal to right side minus g sin theta. Implies that we send this part right side, and we will get equation 15. Therefore from 15 theta can be determined, and we may find then phi dot equal to h sin square theta. From this we get the value of phi dot and then phi. Thus dynamical system is completely determined. Now we have an important note. Note is, if a rod is of mass m and length 2a, then kinetic energy T of the rod may be obtained by assuming the masses m by 6, and 2m by 3 placed at two end points and middle point respectively, and we will get the same value of the kinetic energy as we have already calculated by the method of integration. Now we describe this. Since from equation 2 in the solution of the main problem, equation 2, we have seen that the velocity of a point Pxyz at a distance r from the fixed end point O be velocity square equal to r square under bracket theta square plus sine square theta phi dot square. And also from 4 we have obtained kinetic energy T of the rod 2 by 3 ma square under bracket theta dot square plus sine square theta multiply phi dot square. Now we use this method. Let G be the middle point of the rod. Therefore, length of OG will be A, because total length OA equal to 2A. Hence, middle point will be at a distance A from the fixed point O. Let velocity of G and A be Vg and Va respectively. Since the rod is turning, so in this process the position of G will be changed. Consequently, we will get the velocity of the point G. The velocity of the point G is denoted by Vg and velocity of the point A is denoted by Va respectively. Since here we have seen that a point at a distance r from O, the velocity square of that point equal to r square under bracket theta dot square plus sine square theta multiply phi dot square. In place of r for Vg, we write A. So Vg square equal to A square theta dot square plus sine square theta phi dot square, putting r equal to A. This is equation number 3. Now Va square, the velocity of the point A, which is at a distance 2A. Therefore, in place of r, we put 2A. Va square equal to 2A whole square under bracket theta dot square plus sine square theta phi dot square, putting r equal to 2A. This is number 4. Velocity of the point O be the fixed point. So V0 square, Vo square equal to 0. This is number 5. Now we follow this process by assuming the rod massless and placing the masses m by 6 at the point O, m by 6 at the point A, and 2m by 3 at the point G, middle point, respectively. Now, kinetic energy of the rod T will be half. Here we have mass m by 6, mass m by 6 multiply velocity V0 square, plus half here at the point A, m by 6 mass velocity of A square, plus half here mass 2m by 3 velocity of G square, implies that kinetic energy T equal to half m by 6 V0 means 0, velocity at the point O be 0 square, plus half m by 6 Va square be 2a square theta dot square plus sine square theta phi dot square, plus half 2m by 3 Vg square. Vg square is a square theta dot square plus sine square theta phi dot square. Here this is 0. We take common theta dot square plus sine square theta phi dot square from this and this term. Here remains half m by 6 2a square means 4a square. Here half 2m by 3a square. By calculating we get this m by 3a square plus by calculating we get this m by 3a square. By adding this we get 2 by 3 ma square and this term theta dot square plus sine square theta phi dot square. This is number 6. Here in 2 we see that this value of kinetic energy was calculated by the method of integration, and this value kinetic energy has been calculated by assuming that we place m by 6 masses at the end points of the rod and 2m by 3 at the center of the rod, middle point of the rod, and we get the same value. So without integration, by assuming this concept, we may also calculate the kinetic energy of a rod. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.